Hello and welcome to our presentation for our work submitted to the ninth Social Media Mining for Health Research and Applications 2024 Shared Tasks. The title of our work is RoBERTa Ensemble for Identifying Children's Medical Disorders in English Tweets. And this project has been worked on by Azmine, Toushik, Wasi, and by myself, Sheikh Ayatur Rahman. So moving on, we tackle task 5 of SMM4H shared task, and the basic description of of this task is that it is basically a binary classification task where several tweets are given, and we have to essentially like classify these tweets based on whether after having reported a pregnancy, the mentioned parent has also had a child with specific disorders such as ADHD, ASD, delayed speech, or asthma. So if the tweet suggests that the child has a specific disorder, it will be labeled as 1. And if the tweet does not suggest that the child has a specific disorder, it will be labeled as 0. So what is the purpose of this kind of task? So this task enables large-scale use of Twitter data for various studies and to understand what kind of experiences parents had with targeted support and intervention. So in this dataset, we had like 7,398 tweets for training, 389 for validation, and 1,947 for test. So moving on, what was our approach to this task? So first of all, we essentially like tokenize the we simply just tokenize the tweets using the RoBERTa tokenizer from Hugging Face. And as for a model, we used a backbone which we used a backbone of a pre-trained model like RoBERTa or BERT or RoBERTa large and RoBERTa base and like these search variants. We also used an additional backbone which was posted by the user Cardiff NLP from Hugging Face, which was Twitter RoBERTa based sentiment latest. So this model was developed by Times LMs and then fine-tuned by Tweet NLP on the Tweet Eval dataset developed by Barbieri 2020. So the reason for using this dataset is that is using this pre-trained model is that it has been fine-tuned previously on Twitter data, and we hope that this will and our idea was that this would be relevant to our task and would actually outperform other models as well. So that was the initial approach. We also so our approach was basically separated into two different approaches. First we trained like individual models, and then we took those models, selected the best models, and essentially assembled their outputs to get a final prediction, which we did using the voting classifier, meaning that the we essentially held a vote for the top three models essentially held a vote, and the class which got the most votes essentially was selected as the final prediction. So this was so moving on, we kind of we look at the specific implementation details. So for tokenization, we used a maximum length of 256 tokens along with lowercase text processing. As for the model architecture, after being like, as we can see over here, after being passed through the like pre-trained classifier, we pass it through another dense layer which acts as a pre-classifier, then pass it through a dropout layer, then another classifier, then another linear layer which performs the final classification. So for the dense layers for both the pre-classifier and classifier, we use 768 nodes, and we use sigmoid activation function with zero point 0.3 dropout for our like the final best performing models. As for batch sizes, we use like 8 for training batch size, and for validation and test, we use 4. For the training parameters, we use the learning rate of 1 e to the power minus 5, and for loss functions, we use binary cross entropy loss since it is a binary classification task with add-on optimizer. So and all the random seeds in our experience were set to 101. And as for the training process, we trained each model for 10 epochs, and we did not use any additional data. So looking at the results on the training and validation set, we can see that we kind of like varied the backbone using models like BERT-based, RoBERTa-based, RoBERTa large, as well as the kind of like the Twitter fine-tuned RoBERTa, which we talked about previously. And we also and we also had we performed an ensemble of the top three models. So we can see the results over here. All of them are pretty neck and neck. As for validation F1, we can see that the ensembled models as well as the kind of like the Twitter fine-tuned models perform the best. So moving on the test set, we submitted two models for our final kind of like classification. So one of them was the kind of ensemble model where we picked the top three best performing models on our validation F1 set, and the other was essentially just like one single model, which was the kind of like the previously previous the RoBERTa model that was fine tuned on Twitter data by Cardiff NLP, and then we further fine tuned in on our task. So as we can see in the results over here, is that as far as F1 score is concerned, our ensembled model got a very high F1 score of 0.898, and the single model got an F1 score of 0.892. And the F1 scores are like macro F1 scores over here. We can see that our both of our models actually outperformed that median macro F1 score for this task, which was at 0.822. So for the final kind of like best models, we used a dropout of like zero point 0.3, and we trained the model for 2 epochs. After which like overfitting kind of like sets in, since it was like already kind of like fine tuned. And we also like yeah, this was the best performing model that we got. So moving on, we can take a look at the validate. We can take a look so moving on, like we're in conclusion, like we can kind of like conclude that using the pre-trained language models like RoBERTa and BERT was actually was an approach that did work really well, and essentially like fine-tuning them using MLP classifiers was an approach that did work well, and in particularly the Twitter fine-tuned data model did actually like kind of like slightly outperform the other models. We also like made like kind of like we also fine-tuned some of the hyperparameters, and we're kind of like find a set of hyperparameters that actually enhance and maximize the performances of our models. And additionally, an ensembled models, our ensembling approach actually allowed us to kind of like outperform the kind of like singular models by a very small margin, and it also ensured that we got like stable results in our testing. And as for the final results, we our top models achieved an macro F1 score of 0.898 and 892 on the test set, demonstrating that our model actually worked pretty well, given that it outperformed the kind of like the mean F1 score that was achieved on this task. And that brings us to an end of the presentation. Thank you very much.